Today I'll be explaining the graphs of polynomial functions. Here are some important terms you'll need to know. The leading term is the term whose variable has the highest exponent. The leading term of the function f of x equals negative 4x to the 7th plus 5x to the 4th minus 2x plus 10 is negative 4x to the 7th. The leading coefficient is the coefficient of the leading term. The LC of the above function is negative 4. The degree of a term of a polynomial function is the exponent on the variable. The degree of the polynomial is the largest degree of all its terms. The degree of the polynomial function above is 7. The zeros or roots of a function are the x-intercepts. In order to predict the graph of a polynomial function, you must use the leading coefficient test. There are 4 cases to consider in this test. If the degree of the leading coefficient is odd, and the leading coefficient is positive, the graph points down on the left and up on the right. If the degree is odd and the LC is negative, the graph points up on the left and down on the right. If the degree is even and the LC is positive, the graph points up on both the left and the right. If the degree is even and the LC is negative, the graph points down both on the left and the right. Let's try an example, number 12 on page 343. The leading term is x to the third, which has a degree of 3, which is odd, and a positive coefficient of 1. The graph must therefore point down on the left and up on the right. The second step is to make a table of values. Simply plug in values for x to find y, which would provide you with the coordinates you'll use to graph. Once you've graphed enough coordinates, your overall graph should look the same as the shape you predicted using the leading coefficient test. Next, we will determine the locations of any real zeros or x-intercepts. We see one in this graph located between the x values negative 1 and negative 2. Finally, we will locate the points at which the relative maxima and minima occur. These are represented by the humps in the middle of the graph. The highest point can be seen over the x-coordinate 0, and the lowest, the minimum, can be seen lined up over the x-coordinate 1. Let's move on to another example, number 11 on page 343. The leading term is negative x cubed with an odd degree and a negative LC. The graph points up on the left and down on the right. We move on to the table of values. Plug stuff in on x to find y. Now graph the coordinates. Next, locate any real zeros. They can be seen at the x-coordinates 0 and negative 4. Finally, we look for the relative maxima and minima. The highest point is at the x-coordinate 0 and the lowest point is about the x-coordinate negative 3. The problem is finished. A real-world application of polynomial function graphs is to model the phases of an event such as a sickness. This concludes this lesson.